So we're continuing with the exploration of a semi-cylindrical roof. Okay, so here's a roof and a hole that was drilled atop this roof, which if viewed from above is perfectly circular. So if you think of a cylindrical drill as drilling a hole uh, over another cylinder of bigger radius, you get something like that. You get you get this circular hole at the top area of this cylindrical shell. Okay, now what I'm interested in is actually exploring variegated shapes of what this hole looks like from different viewpoints. And you can see here that it can look like a convex curve uh, to something that is non-convex, like so. You can see here that you have some areas of negative curvature. To, yeah, let's show another one of those. For example, like that, negative curvature. You can see that from underneath the shape as well, right? So if I'm looking underneath the shape, I can have a non-convex projection. But if I look uh, closer to the axis of the hole, it becomes convex. So there's a transition point here where some critical point will assume a zero curvature, beyond which the projection is convex. So there's this transition. And then another very interesting phenomenon is what are viewpoints, say on a viewing sphere, for which the curve will have a cusp. So here's a cusp, and you can see that the cusp always happens at the transition. As I roll this thing further down, okay, uh, from a simple curve going through the cusp to a self-intersected curve. So now the projection is self-intersected. Of course, I'm making the shell be slightly transparent so I can see the outline circling under itself and back, right? The curve itself in 3D is never self-intersecting. In fact, this is a quartic of some kind. This is a space curve of degree 4. However, there are some critical viewing angles for which the curve will exhibit a cusp. There seems to be a locus of such points. For example, if I rotate the sky a bit, I can always find a new angle for which a cusp is visible. Let's rotate it some more. Now you can also find that cusp location there. And if you rotate it completely, then you get an interesting saddle kind of thing where if you're looking at the curve exactly from the side under orthographic projection, you can get a situation where the curve is basically going to retrace itself in the projection, and you're going to get these two degenerate cusps, right? So this is a degenerate position. Um, Another thing, if you're looking at it from, a pretty, let's say, vertical view angle like so, you can never form a cusp. So for example, if I rotate about this higher view angle here, okay, and I'm just rotating about the equator, for example, you'll never be able to form a cusp, okay, because you are high enough, or let's say you're viewing this from an angle that is more aligned with the axis of symmetry of the hole, okay. So if I just rotate the shape like so, okay, you can never see that. Now, another way to illustrate this is by doing this in a controlled manner. So for example, if I am rotating this shape from a high enough angle, like so, okay, you can see that the outline will never become self-intersecting. You'll never become self-intersecting. Now, if I make my view angle become more horizontal, like so, then clearly there will be equators of my viewing sphere that will cause the self-intersection. Now, it's the transition of the curve not being self-intersected to it being self-intersected. Okay, so if I can do this by hand, for example, right here, where the cusp is located. And the cusp always seems to be located at the silhouette, okay, the silhouette of this shape. I'll look at that other beautiful configuration there. Over here, we have a cusp, right? So we have this teardrop shape, which we saw above, right? It's the teardrop shape, where you get something like that. You're looking at it from, yeah, so there are these positions here where the curve has symmetry. Okay, so there should be a locus of those as well. But I was particularly mesmerized by these teardrop cusp kind of curves. Anyway, so there's very rich geometry here. There will be extensions of this. For example, what if this is not a cylinder of circles, you know, the rooftop, but it is a cylinder of some other continuous curve, such as a parabola or an ellipse? Does that make the problem more complicated, less complicated? Um, this is to be analyzed. All right. So once again, happy 2025, and I'll see you soon. Bye.